for today, you have to know how to graph. That's why I gave you this problem. So I'm first going to subtract my 2x. I know, it's been doing it all day.
Oh, boy.
I don't know what's going on. It's got a case of the Mondays. Subtract my 2x over. So I have 3y. Okay, shh, stop talking. Equals negative 2x plus 9. And then what do I need to do? Divide by 3. So I have y equals negative 2/3 x plus 3. So where do I start this graph?
Up 3.
Up 3. And then my slope is what?
Down 2, right 3.
Okay, so down 2 over 3. So here would be your line. So today what we're going to do is we're going to do linear systems, which just means more than one linear line. And we're going to find a solution based off of their graphs. So you have to be able to do this today. So go ahead and grab your notes for 3.1. 3.1. Watch.
Yeah, I can watch.
Okay, so here is what we're learning to do today. Okay, let's just watch though. We're going to find where the graphs, we're going to find a solution that works for both of the two lines. That's the idea of linear systems. Linear systems means more than one linear line. So I'm going to give you two equations. We're going to start with this. Negative 3x plus 2y equals 8. And x plus 2y equals negative 8. We want to find what point is true for both of these. The way we're going to find that is we're going to graph them and see where they intersect. The intersecting point is your solution. You guys all did this in Algebra 1, but there's 3 ways in this chapter. There's graphing, what we're doing today. There's elimination, and there's substitution. Those sound familiar to you at all?
Yeah.
Okay, I mean, you have all done it, but for some reason, Algebra 1, it doesn't get mastered, so we do it again in Algebra 2. So the first thing we have to do is solve for y for each one of these, just like we did for the bell ringer. So I'm going to add 3x over, so I have 2y equals 3x plus 8. So this line is going to be y equals 3 over 2 x plus 4. So this is line number 1. Line number 2, we're going to subtract x over. So I have 2y equals negative x minus 8, divide by 2, divide by 2, divide by 2. So line number 2 is y equals negative x over 2 minus 4. Okay? Everybody good with this? Now, since you're not on graph paper, I'd probably say your homework, you might want to grab a piece of graph paper. They're always in the back. You have to graph this very carefully so that you find the true intersection point. So the first one, I'm going to start up at 4. And then I have to go up 3 over 2. Like that. I probably should have kept my slope going. So down 3 over 2 will be right here. Okay, we'll see if this intersects. It's going to. We'll see if we can see on my graph. The next one, we start at negative 4. And we go down 1 over 2. That's what I thought was going to happen. So we have to try to guesstimate what this is because I'm not on graph paper.
It's like a
I'd
negative.
say 3, 4, negative 4. I'm going to guess.
I said negative 2, negative 4.
So reverse that.
Part of the positive 2.
No,
Or what?
reverse negative 4, negative
Oh,
2.
So it'd be
And that is the answer, negative 4, negative 2.
negative 4, negative 2.
So we're looking for this spot right here, which is negative 4, negative 2. If you guys are on graph paper doing this, you'll be able to see it exactly. When you're drawing it on the board and you're making your own tick marks, it's maybe not as exact. But this one actually worked out.
Is that the only way to figure out
Is
graph?
graphing. No, we're gonna do elimination and substitution, but today we're just doing graphing. This is Erin Harrington. Hi. Yep, thanks, bye. Through the new office.
Okay.
Okay, the only other thing I'm gonna show you is, there's also, if you remember from substitution and elimination back in those days, you either got a solution, or you got no solution, or you got infinitely many solutions. Think what type of graph would give you no solution?
Two negatives.
Parallel lines. Because what do parallel lines not do? Intersect. And our answer is where they intersect. So if you get two lines that are drawn as parallel lines, then we know they're not, it's gonna be no solution. Okay? And then the other one is if you get the same line, one graphed over the other one, then you have infinitely many solutions. So here's what I want to happen. I want, from Jaden over here, I want you guys to graph this graph. Y equals 2x minus 3 and 6x minus 3y equals 9. So that's this half the room. And then the other side, Reagan over to the door, we're going to graph negative 3x plus y equals 4 and 6x minus 2y equals 10. Okay, so graph those two lines and see what the graphs look like. Could you take that downstairs?
The chair?
Yeah.
Yeah.
And put this on there. Huh? But if it's the same line, it'll touch it infinitely many times. Ask them if that she's gonna come with this chair. She's gonna put that on the chair. Yeah. And then two things. I printed some stuff. So we put that, right? And then will you make a copy of every side of this and take it to the new teacher, Miss Hicks?
The one goes with you.
Yeah.
What do you mean? How do I do it? What do I put on this picture?
That's that one. Just go copy and then you can go to the two-sided and copy it, or just put them on the screen for each individual side. Good luck.
Stapled?
No, they don't, oh, it doesn't need to be. If you wanna get fancy, you can.
Alright.
Okay, the window group on this side of the room. What did you notice when you graphed these two lines? They're exactly the same, just one. Yeah, and then take that copy over to the new Mrs. Carroll. Okay, and at this point right here, you could see this line is exactly this line. So if you graph the same line twice, negative 3, up 2 over 1, and then you do the same thing again, you get the same line. How many times is it touching, how many times is it intersecting if you have the same line? Infinitely many times. So when you get the same line, you say like infinitely many solutions. What did we find happen here with these two lines? Okay, put your phone away. What happened with these two lines, this side of the room? They are parallel. So when we graph this, we got y equals 3x plus 4. And over here, I subtract my 6y, or my 6x. And when I divide it by 2, I get y equals 3x minus 5. So these two lines are same slope, but different b values. So in this case, you get parallel lines. So what do I write for my answer for these two? No solution, because there's no place that they're going to intersect.
Is that parallel?
Yep.
Sorry, I was.
Okay? Easy enough today? So I'm going to give you guys one to do on your own, then I've got a handful of problems for you to do. Okay, last one for today. If you all get it right, then we're done. X minus 2y. Okay, Drew Gleason, you have got to stop talking. I'm going to have to move you to the back if you can't do this. You can do it. I know you can. Okay, so I have x minus 2y equals 4, and I have 3x plus y. Ooh, does that bother anybody?
Yeah.
It would me.
Yep.
That I wrote my y's differently.
Oh, yes, yes, yes.
If I was a student sitting in the room right now, I would be
No.
going nuts.
I wouldn't have
Just saying. And probably this mark up here. Okay. Equals 5.
noticed. Or that you didn't scroll down all the way.
Or that there's little things here. That would drive me nuts. But right now, this is what's making me crazy, and I do it. So whatever. Okay, graph these two, see where they intersect. They're going to intersect at a nice number, so graph them carefully. When you're done, turn to someone around you and see if you got the same answer as them.
Right backwards. How's that? So I did the y, and then did the, oh, I did make a negative.
That's what it was.
That's what's going on.
Okay, I'll do my work up here and then we can compare.
Yeah.
No, I got a negative 4.
Did you guys get it to go to a good little, one little easy?
Yeah.
Right on
Positive
there.
2, negative 1.
Okay, so I have -2, up 1 over 2. And then I have +5, down 3 over 1. So 2, -1. Everybody good with that? Okay, here is your assignment for today. I need to look at this.
Keep your hands to yourself, please.
Okay, I want to go, we might go over this today in class, we'll see. But we're on page 138, 7 through 12. If you'd like to use graph paper, it's back there on the right next to the Algebra 2 books back there. But this is, I'm giving you 6 problems to work on. We should be able to go over this in class.